Okay, so this is Julius. So
And
here is
today we
the
are about to learn how the full
input
adder
and
works. But in this diagram, you are seeing
the
it's
three
a
inputs
combination
here.
of a
The
full
OR
adder
gate and
with
NAND
some
gate.
logic
Another one.
gates
I'm trying to
connected
explain.
to a
Oh, my
multiplexer.
mic.
The multiplexer here is just to
So
we are just using it to select
the input
which
here,
input
you take
to
the
the
OR gate here.
multiplexer should be displayed.
The
Either
OR gate here. So
this,
if
which
you
is the
go
AND
there
gate,
and
should be
click this
displayed,
one,
or this, which is the OR gate, should be displayed, or the sum over here to be displayed, or the carry out should be displayed. So looking at this diagram, you will see we have two types of inputs, right? You see we have two types of input. We have input A, input B, and we have the carry in input. You see, you also realize that when I was going through it, I mentioned sum here and I mentioned carry out here. So a full adder will be like when you have two inputs, let's say 1, 1 and 0. Maybe you have three inputs. If here was 1, if here was 1 and here was 0, if you add all of them, you get 2, right? So 2, you get 2. So 2 in base 2, you will get 10. So the rightmost unit will be the sum, and the leftmost unit will be the carry out. So here will be 1, here will be 0, and here will be the 1. So that's how it works. That's a mathematical idea behind it. So let's start with it. So let's start with what we first learned, for which it was the 1, 1. So by looking at the diagram, you will see that when we selected input A to be 1 and input B to be 1 and the carry in input to be 0, you will see that the sum here is 0 because there's nothing passing through it, so it is 0. And the carry out here, there's something passing through it, making it 1. So the selector here is to select which input to the multiplexer should pass through to the output. So let's say the first input to the multiplexer is a 0, 0. When the selector is 0, 0, it selects the first input, 0, 1, the second input, 1, 0, the third input, and 1, 1 is the last input. So let's go with 1, 0 to select the 1, 0 to select the third input. So you see the third input, which is the to the multiplexer, which is the sum, is 0. You could see straight up when it is 1, 1. As I told you, 1 plus 1 gives you 2. In base 2, it becomes 1, 0. So the rightmost figure, which is the 0, becomes the sum. So you see 0. And the rightmost figure, and the leftmost figure becomes the carry out, which is the 1. So if we move the selector to 1, 1 to select the fourth input to the multiplexer, you see it's 1. So the carry out becomes what's 1. So let's say if it was just maybe the first input A was only 1 and the rest of the other input, which is B and the carry in, are all 0, 0. You will see that the sum has highlighted green. The line here has highlighted green because the sum is 1 and the carry out is 0, because when you add all this together, you will get 1, and in base 2 it will be 0, 1. So if it is 0, 1, the rightmost unit is 1 and the leftmost unit is what? 0. You get me? So let's say all of them were on, which is 1, 1, 1. You will get what? 3. 3 base 2 is 11. The leftmost, which is the carry out, is 1, and the rightmost, which is the sum, is 1. So you see here the green line has been highlighted. What? Here the sum has been highlighted green, and the carry out too has been highlighted green. So if our selector 1, 1, which means the fourth input to the multiplexer, has highlighted, meaning it is allowing the output of the multiplexer as input to pass through to the output. So you see it has highlighted green, meaning here is 1. Then when you select the third input to the multiplexer, you see when it enters the multiplexer, you see that one, it has allowed it to pass, showing us that the sum is also 1. So meaning when it's 1, 1, 1, when you add 1, 1, 1, you get 3 in base 2 is 1, 1. The sum becomes 1, which is the rightmost value, and the carry out becomes 1, which is the leftmost unit. So let's say the selector. So the selector just selects which input to the multiplexer passes through to the output. So let's say if it was 0 0, and let's make here 1 1. Let's just make input A1 and input B1. Then you see 0 0. You see that the first one has passed through. 0 1. You see that the second one has passed through. So the multiplexer was just acting in this diagram. It was just acting as a selector which selects which output should be displayed at the output as the output. You get me? So yeah, that's it. So that we don't get confused. So this is all about when it comes to a full adder, how it works and things, and also explaining a little bit about the multiplexers. Thank you for watching. Like and subscribe.